Okay, so in numbers 9 and 10, they're not traditional rationals because they have a radical in them. And in traditional rationals, we compare the degree of the numerator with the degree of the denominator, and that way we can figure out our horizontal asymptotes. So even though this isn't traditional, I can still figure out what the leading term of this numerator would be. I don't really know how to take the square root of a binomial, but I know that the leading term will be whatever the square root of the leading term is, okay? So if I were to like simplify that out and just figure out what the leading term would be, the square root of 2 would stay the square root of 2. You need another pass? I threw it out. Oh, she is, tell her thank you. Tell her that I appreciate it. Tell her. Okay. I appreciate that she's following the rules. I love it. In fact, if I were running the building, you would hate me. I'm just kidding. You wouldn't. You'd be used to it. You'd just follow the rules, maybe. That's very idealistic. That's just like impossible to make happen. But anyway, the square root of 2, what's the square root of x squared? Yeah, that's what you all think. Not true. Because what if x is negative 5? Is the square root of negative 5 squared negative 5? The square root of negative 5 squared is negative 5? No, right? Because order of operations says we have to square this first, we get 25. The square root of 25 is not negative 5, it's 5. So it's the absolute value of that. And we did this like very early on in the year, right? So the square root of x squared, when you were younger, yes, okay, it's x, we got away with it. But in reality, it's not x. If x is a negative number, that's wrong, right? So we protect against that, and we say that the square root of x squared is the absolute value of x. It only applies if you have an even root with an even power. It's the only time you have to worry about that little, like, special situation. But it's the absolute value of x, and then who cares what the rest of that polynomial would be if we took the square root of it. And the denominator is 2x plus 3, but we don't even care about the plus 3. All we care about is the leading terms. So if we were following the degree rules, this is what? Same over same, which goes by the coefficients. But the horizontal asymptote, there actually is going to be a positive version of it and a negative version of it, thanks to those absolute value symbols. So you have two horizontal asymptotes, one at positive root 2 over 2 and one at negative root 2 over 2. As you head off towards one of the infinities, so now let's think about that. If I were plugging in infinity, like a positive infinity, the numerator is going to be positive and the denominator is going to be positive. So it would be approaching the positive root 2 over 2 asymptote as you go towards positive infinity. But if you're going towards negative infinity and plugging in gigantic negative numbers, the numerator actually will still be positive and the denominator will be negative. And that positive divided by a negative has us approaching a negative root 2 over 2 asymptote. Does that make sense? So when you take an even root of an even degree power and try to apply those horizontal asymptote degree rules, if it's a same over same, there's actually two horizontal asymptotes when there's that absolute value involved. And that is rare, but it happens. Okay? Similarly on this one, if you look at your leading term, it'll be root 2 and then the absolute value of x. Who cares about the rest? This one will be 4x. So again, it's same over same. So we go with the coefficients root 2 over 4. But because of those absolute value symbols, it's plus or minus root 2 over 4. So we have two horizontal asymptotes. As we head towards positive infinity, a positive over a positive would put us leading towards the positive root 2 over 4 horizontal asymptote. And if we plugged in a negative infinity, it would be a positive over a negative, which would lead us towards the negative root 2 over 4 asymptote. I'm going to plot number 9. boy. Square root 2x squared plus 3 divided by so if I zoom 6 on something like this, you'll see as you go towards negative infinity, it's flattening out, and maybe this is a lot of wasted space, so I'm going to go on my window, I'm only going to go from like negative 5 to 5, and then maybe I'll go from like negative 100 to 100. So you can see as you go towards negative infinity, it's definitely flattening out on the negative root 2 over 2. And as you go towards the positive infinity, it's flattening out at the positive root 2 over 2. You can't see those values, but if you actually plotted those asymptotes, you would see them kind of thread the needle there. And this one's increasing towards that one. Gosh, negative 5 to 5 is even a lot. We really only need negative probably 1 to 1. And then there's your horizontal asymptote. So that blue line is increasing towards it, and this blue line is going up and up towards that as well. So two horizontal asymptote situations, one guiding end behavior in the positive direction, the other one guiding end behavior in the negative direction. Okay. Your homework, we obviously didn't do anything new today. This is going to be a little bit backwards, and some of you are already done with it, but it's to do the quiz review packet, the odds. So I know like some of you already have that done. Good, you're done. But just to keep these items fresh and so we can ask a lot of questions on Monday, your review, so it's 1 through 32, so it's about somewhere around 16 problems, 16, 17 problems. Is it? Oh yeah, you don't count both ends. You're right. Yeah. Good. Okay? The review packet is on my webpage, so if you